Hey everyone, welcome back to Unit 6, Triangle Congruences. Today we are doing the third and final section of this unit. We are writing a flowchart proof for any one of those triangle congruences we've covered previously. So our learning objective is, I can write a flowchart proof for triangle congruence using side, 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 angle, or angle, angle, side. Some time ago, we talked about proofs and we practiced using two-column proofs. We will slowly work our way back into that. And the reintroduction to it is through a flowchart. Flowchart proofs in triangle congruence can always have this form, where you have a statement in the box, and then the reason below it, another statement, and the reason below it, and then a third statement, and that reason below it. And each of those statements is going to feed into the conclusion that we're going to draw. And that's going to have to deal with triangles are congruent. As we go along in our geometry careers, there will definitely be a period of time where there will be statements that we can make after we come up with this triangle congruence. And there are definitely times when statements could come before the information that would go in this flowchart. But for right now, the only thing we are concerned about is coming up with the flowchart or a two-column proof that proves two triangles are congruent. So here is how this will be structured for any one of the four triangle congruences we already know. In order to use side, 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 the three statements that would be going in the boxes would all be congruent statements related to corresponding sides between the two triangles. And that would prove that the triangles were congruent by side, side, side. If we ended up with writing two congruent statements about corresponding congruent sides, and we were able to write a congruent statement about the corresponding angles that are included between the congruent sides, then we could write that triangle congruence by side, angle, side. And the same logic, the same thought process follows if we are able to write congruent statements for two corresponding pairs of angles. And then if we have a non-included side that we can say is congruent, then we can call those triangles congruent by angle, angle, side. And finally, if we can make congruent statements about two pairs of corresponding angles and the included sides are congruent, then we'd have congruence by angle, side, angle. We can think of this breaking down in a very similar way to a two-column proof. If you remember way back, where we had our left column would be our statements, and our right column would be our reasons. And depending on your teacher, they probably give those different titles, but the first thing would be all the information that you were given. And then we could start to walk through a logical argument. We're just taking a step back on the formality of this and focusing on the logical argument we're trying to build. So let's take a look. In your notes, I want you to copy down the given and the diagram. Mark up your diagram and then think, what could you prove? So in this first example, given AC is congruent to DF, well, AC and DF are both side lengths, so I'm going to put one tick mark for each of those to show that they are congruent. Then angle A is congruent to angle D, so I'm going to put one arc through each of those angles to show that they are congruent. And finally, the third thing we are given is AB is congruent to DE, so I'm going to put two tick marks in each of those. Now, judging by the shapes of these triangles, how they're both scalene, we can pretty clearly come up with the corresponding sides that we either know are congruent or assume would be congruent. So I just started for triangle CAB. I didn't want to go alphabetically because that can get boring. So I started with C, and then I moved to the angle that was marked as congruent, and then I went to the final side. So with the other triangle, that would start at F, and then we move to D, and we end at E. So if we wanted to, we could set this up as a two-column proof. So the left column is going to be our statements, and our right column is going to be our reasons. Remember, whenever you are doing any two-column proof, the first statement is always going to be everything that you are given, all the information that you're given in that, it says it right there, given. So I'm just going to copy all of that down. And the reason why I can say each of these things are true is simply because they were given. Now, that part of a two-column proof is something that we practiced plenty some time ago. And from there is where we start to navigate which one of our triangle congruences we can use. I want to look at this instead of a two-column proof. I want to look at it as more of a flowchart, more of a way that your brain thinks about this. So I have the exact same problem, except for I already have the diagram all marked up. So now I'm going to go through and list out the corresponding congruent pieces that we have. So the first thing is AC is congruent to DF. And why can we make that statement? Well, that was given. And that's a side length. AC and DF, those are sides. So if you wanted to make a note somewhere that that was a side, you could. You don't have to make that note. The next statement, if our eyes are traveling clockwise at this point, angle A is congruent to angle D, and that's also given. Well, that's not a side length that we're comparing, that's an angle. And then lastly, we have AB is congruent to DE. Also, it was something that was given. And that is, once again, a side. We'll keep it color-coded. So judging or putting together the information that are on those small little letters there, we have side, side, side as the reason those two triangles are congruent. And if you had copied this information down from the previous slide, or you just, it doesn't matter the order that you name your triangles in, as long as the corresponding parts are named in the same order. So the way that they did it here was ABC is congruent to DEF. If you were treating this like a two-column proof, this would be your statement, and this would be your reason. Your statement, your reason. And because all of those three things that would be statements are all technically given, then you're writing them down first anyways. And the only other step, so your step 2 in this particular one, would be that congruence statement, and the reason for that is side, side, side. We proved it. We got there. We got to that ending destination. So let's try another one. Same thing. In your notes, copy down the given and the diagram. Mark up your diagram and think about what could you prove. You need a lot more room on this one. So we are given that ST bisects MA and MT is congruent to AT. Well, bisect, remember, that means to cut in half. Or two equal parts. So that means ST bisects MA. So then I can put a little hash mark there for each of those, because those two, MS and SA, are congruent. When we're looking at what triangles we could prove to be congruent, I'm going to take out my highlighter again. And we have this one on the left-hand side and this one on the right-hand side. So if we were thinking about doing two-column proof, statements and reasons, we could go through that. I'm actually going to use this flowchart proof first to come back to what the two-column proof would look like, because I think this is a good one to illustrate that point. So let's do just that. Like we said before, MS and AS are congruent. Why are those congruent? That wasn't given. I didn't say that those were congruent in the given. What I said was that ST bisects MA. So the reason why we can say those two pieces are congruent, we'd say that that is the definition of a bisector. And the two things we said were congruent were sides. The next statement we could use, MT is congruent to AT. Well, that's going to help us. That's also another side. And the reason why we can make that statement is because that information was given to us. If we look in our given information section and on our diagram, we don't have anything about any angles. So we can't really make assumptions unless you see something I don't. So that means we have to look at this last side length for each of the triangles. In triangle MTS, that is the third side. The one that I put the 3 tick marks on. It's also the third side of the green triangle ATS. So in each of those triangles, we need that side to be congruent. Well, that's weird. That side is the same thing. It's both ST. This goes way back in our proof reasonings that we did months ago. The reason why we can say something is congruent to itself is the reflexive. I'm going to spell reflexive correctly because thinking, talking, and writing at the same time cause problems. Reflexive. If you don't remember the term reflexive or reflexive property, you could write it's the same thing. ST is ST. It's the same thing. So looking at the things that we could say were congruent, all three of those are sides. So that means that those two triangles are congruent because of side, side, side. Now here is where I want to turn this into a two-column proof, this flowchart that we did. Left side are the statements. Right side is the reasons, proper grammar. So the first statement we always do is just dump everything that was given to us. So in this problem, it is ST bisects MA. And MT is congruent to AT, right? MT is congruent to AT. And the reason why we can make those statements is because they're given. Remember back to when we were doing proofs, I always had part of the structure that you could do without knowing any particulars of the problem. That is this part in purple. That's the structure that you don't need to know anything about this particular problem. You're just copying down the statements and reasons and the information that's given. Now we can look back at our flowchart and start to fill in any information that we wrote in that flowchart. So MS is congruent to AS. And why can we say that? Well, that's that definition of a bisector. Definition of a bisector. Or you could just say, because it's a bisector, that is okay for now. The second statement that we made in our flowchart proof, MT is congruent to AT, that was given, so we don't have to say that again. And then the last part of our flowchart proof was saying that ST was congruent to itself. And that's because of the reflexive property. If you don't remember the reflexive property, you could say because it's the same thing as itself. Now that we have all three of those statements, then we can make our final conclusion that those two triangles are congruent, MTS and ATS. You cannot say prove. Prove is not a reason. The reason that we can say that those triangles are congruent is by side, side, side. And that's your proof in two-column form. For this final example, I will let you decide which way you want to do, either the flowchart proof or the two-column proof. I'm going to do the flowchart proof because I like the artistic nature of it. So again, as always with this, copy down the given and the diagram. Mark up your diagram and think about what you could prove. So in this problem, angle TSR is congruent to angle TUR, and RT bisects angle STU. Well, good thing I'm not having to do a two-column proof. I am going to do a flowchart proof. So the given information of TSR is congruent to TUR. TSR is congruent to TUR. So that gives us those two angles there that are marked with one tick mark. And then the other bit of information we're given is that segment bisects that angle. That segment RT bisects angle STU. So that creates those two smaller angles that are congruent. So I marked them with two tick marks. Let's fill in that information in our flowchart proof. Angle TSR is congruent to angle TUR, and that was given. But saying that these two small angles, which we marked on our diagram, angle STR is congruent to angle UTR, that wasn't given to us. We only were able to come up with that after we worked with that statement, that RT bisects that angle. So that is the definition of an angle bisector, or you could say bisector, because it's still performing the same duty. And the last bit we have, if you're struggling with what piece we could come up with, look at the information that we have so far. We have an angle and another angle. We haven't used anything called the angle-angle-angle congruence. So we have two options. Looking at our diagram, we see that these two angles are consecutive. So we could either prove that the segment that's between them is congruent, or a non-included one, non-included segment. I'm going to go that route because this segment here, RT, is a non-included side of our triangles, and it's congruent to itself. That reflexive property strikes again. So I am going to draw it in blue. I'm going to slightly fix my color coding. So I'm going to draw it in green. I just retconned that. RT is congruent to RT, and that's because that's reflexive. And now we can say, well, identify that that's a side. Now we can use this information, compare it with what we have on our diagram, to say that those two triangles are going to be congruent by angle, angle, side, and make sure we make that congruent statement. So TSR is congruent to triangle TUR. And there we go. That's how you use a flowchart proof to help you prove that two triangles are congruent.